So let me talk about, switch to yet another selected topic to talk about for a minute. Triggers and trigger masks are a capability that is defined in RFFE that is quite useful in device applications, particularly where there are a lot of devices on a bus. Or when the first example is when there's perhaps a lot of reconfiguration that needs to be done to a single given device. So a trigger offers a means to delay the application of this data. So in less critical times, these configuration settings could be updated and then triggered to occur altogether at one point in time later on. And so there are actually 3 triggers that are defined and can optionally be used within any given implementation. And there's flexibility in which registers are assigned to any trigger one. So these triggers and the masks for them operate independently, and as I said, there's full flexibility in how those are arranged. The first example of how to use them, as I mentioned, is syncing multiple changes in one device and a single slave device to occur at a precise time. Another is to actually perhaps do the same thing, one or multiple changes in one device, and trigger all these to occur within multiple devices out there on the bus at the same time. And that counts on another capability built into RFFE called group slave IDs, which I'll get to in just a moment. Let's take a picture look at this a little bit first. And these are simple diagrams, but as you can see, this is in this example, it's presumed the interface cycle register, by the way, is presumed to be the actual receiving device for data coming in. And until the entire message is received, you're going to keep it held somewhere before you actually write it off into the proper address location, which are denoted by all these registers down here below. The shadow registers are entities that are used to hold the data off before they're actually put into the destination or the mission mode registers. And you notice here that we're showing different registers assigned to one of all 3 of the triggers. And in this case, all of the triggers are turned on, which means the masks are off, so that the data coming in to the device would go to the shadow register in all cases. And only when the trigger was fired would they actually transfer from these registers down to the mission mode registers shown at the bottom. So that, in essence, is how the triggers are set up to operate. An example of showing one of those then being turned off and the action that happens is in the same case, if you look at the trigger 0 registers, the writes that would come into those, or reads that would occur from those, would actually go straight from the interface itself directly to the destination registers, which are registers A and B at the lower left there. So it's simple, relatively simple concept, but very useful and flexible in operation. And it sees a lot of use in applications. So in concert with that, imagine then, as I mentioned a moment ago, that this can be used in multiple devices simultaneously. Some of the slave address IDs that are used to address messages or telegrams to specific devices can also be programmed into what are called group slave IDs. A special case of group slave IDs is one that's reserved. It's called the broadcast ID. And by definition, it means every device that's on the bus. And it's all zeros. But there are others optionally available, should they be implemented in a slave. The ability to program a group slave ID such that in addition to its default or programmed US ID, it would also respond to a group slave ID, which could be one to any number of devices that are hanging on the bus could additionally respond to this group slave ID. The usage of this is really growing or seeming to grow to the working group quite a bit in the industry. And the use of it, again, is that multiple devices then can be loaded up, and the actual reconfiguration data can be delayed to occur simultaneously within all those devices at one time. It's a very useful feature. The usage of them is that, as I said, it takes place all at one time. It allows then configuration changes to individual devices to all be done ahead of time, perhaps at a less time critical portion, and it allows the simultaneity possible of having all of that come at one point in time. So it's more than likely that the reconfiguration data is going to go to each of those separately, although the group slave ID could also be used for that. But in order for that to operate properly, you would have to have actual configuration tables that matched up completely between devices, more than likely from different manufacturers, and that's not likely to happen. So, but it is possible. Note that though that group slave IDs only work for writes and not for reads, which makes sense because you don't want more than one slave responding on the bus or trying to drive the bus at a time. But since this is typically a top-down driven system for RF front-end subsystems, it answers a real need, even being restricted only to writes from the master, the active master at the time. Moving on from that, talk just a little bit about the retention of settings. I mentioned the initialization of devices going to their default USID. There are a number of settings that when VIO goes away, the device is reset. There's also a soft reset that's available in RFFE. The working group has noted already some desire to retain certain settings by users if VIO is not removed. And this is something that we're talking about in the next generation, perhaps. It's not precluded today, but would require some device level means to make that happen. But there are system level abilities to make that happen today, but it really comes about from outside the domain of the RFFE devices or the interface itself, and gets into the realm of the power management system chosen for the system. So there was actually a new section added in the application note, which is 412, I believe, of the application note. This is a diagram from that, where settings could be retained in a system by allowing for power management system to actually take VIO to perhaps a reduced level, a lower current level, in order to save some power in the system without actually removing VIO entirely. But the main points to note here are that this is an area that the working group is still exploring for options within the next generation. Although there are capabilities that are available today that allow that to happen by careful planning at the system level. Topologies is another area that we have documented some, but not thoroughly in the present documentation set. And the plan is to talk about that a little bit more in the next generation, probably in the application note. Right now, the specification shows one interesting topology of interest, and that would be where multiple slave interfaces were actually contained physically within one device. That's a fairly simple case and is probably likely to happen, certainly, but other options are also possible. Note in this case, though, that although what's being depicted here is that although these devices are contained physically within one device, the master really doesn't know the difference. It's addressing the two different interfaces as logically separate, and the master may not even know that they're physically within that device. One reason somebody might do that would be that maybe the device is complex enough that it has two separate control models, or you know, for some other reason that control would need to be segmented. And there could be other reasons for that. But there are a few others that could exist and are not defined by RFFE, but perhaps are of interest. And that would be taking the last example, for instance, and imagining then that only one of those slaves is actually logically connected to the master, and that somehow the data for both of those interfaces was transferred from the master to one of those slaves, and would somehow, through proprietary or other means, or another instantiation of an RFFE bus, make it to the second slave device. This is not precluded, but it's not. It's also to the extent that this second bus would not be RFFE, it would not be covered or mandated by the RFFE spec. Another example that could exist would be perhaps an inter-bus communications interface would exist between one of these devices. Perhaps instead of a second slave, there's a master located out there connected to a different RFFE bus, and you want to have data available to go between the two different instantiations of the bus. This is possible, although again, in this particular case, this bus, unless it was RFFE, would not be controlled or mandated by RFFE, so people would need to work out the details of that in that case, but they're fully free to do so to the extent that it doesn't perturb you know, the operations of either RFFE bus. Today, of course, it would not be allowed for this master to connect as a second master to the red bus, or A bus in this case, because at this point RFFE is a single master system. So that's just a few of the additional topologies. And one of the key working points of RFFE has been that we try to specify what's absolutely needed to guarantee that the devices will operate, but leave outside of that, you know, some flexibility for implementers and systems developers to be able to innovate outside the use of the RFFE bus itself. So, in closing, I'd just like to mention that a next generation specification for RFFE is planned. It will be a major release, as there are some technical updates planned. A major goal of the working group is to maintain compatibility with the current standard. So we want to make a transition to additional capabilities as easy as possible. The application note we see is growing, because that's where a lot of the flexibility and the innovation perhaps could be explained or at least inferred to the user community. A lot of that flexibility is already there. But as we gather data as to what people are actually doing with the interface, it's useful to be able to add user information in a useful way as well for the user community. So with that, I appreciate your time, and I'd like to open up to any questions that anyone might have about either what I've talked about or about RFFE in general. If there are any RFFE users out there, love to hear from you.